about it. Okay, so 13 and 14. Usually I do two different types of warm-ups, but today I was too lazy to turn the page over, so I thought we'd just do these two. All right, so the vertex is -4, 3. I got that from the equation here, and A equals 1, which means that we could sort of cheat with our graphing. -4, 3. Well, this is a weird kind of graph. It's fine. Okay, and A is 1, so we're going to go over 1, up 1, over 2, up 4. And then we decide if it's dashed or solid. This particular one is solid. Completely missed the coordinate. That's fine. Okay, next we're going to test 0, 0. 0, 0 is right here. I'm going to put a little visual marker there so I can see where I'm testing. And I can test any point I want as long as it's not on the parabola itself. 0 is greater than or equal to 0 plus 4 squared plus 3. 0 is greater than or equal to 16 plus 3. And I think that the crocodile would be very unhappy in that situation. So that's false, which means that at 0, 0, where I plugged in is false. And above the parabola has to be true then. And done. Not too bad. Not too bad for Monday morning. Okay. Any questions about 13 before we move on? You guys good? Leo's good. Okay. Next one. Vertex is -2, 1. 2, 1. And in this one, A is -1, which means that we get to use the trick still, but we just need to go downward. So this is also really weird graph paper. That's fine though. No biggie. This one is dashed. Okay, 0, 0 seems to be here. Zero is less than -0 plus 2 squared plus 1. 0 is less than -4 plus 1. Is this false again? Sheesh. False. True inside. And voila. Okay, now look at the weekend homework, please, the mid-chapter. Gosh, Mrs. Saba, your packet's really sparse. You didn't do any of your work. Anything in the mid-chapter that you want to go over that you got stuck on, Thea? Oh, yes. This problem is Spicer-Rooney. Okay. First question I have for you, Thea, is what number is going to be the common base for these? So in this one, the common base is 2. Okay, so let me do this. Let me see if I can okay. Now there's your hint. If the common base for number 7 is 2, what's going to be the common base for number 8? 3. Okay, which means I need to make those both into 3 to those. 81 is 3 to the 4th power. So you do 3 to the 4th power, and then the little r that's there is times. So these exponents get multiplied. And then on this guy, you put a little 1 there, and you move it to the top, and it becomes 3 to the negative 1. Cancel, cancel. 4r equals negative 1. Divide by 4. R equals negative 1. Spicy, spicy, that one. Anything else around the mid chapter? Yes, dear. 5. Tell me that you guys like number 7, though. Oh, yes, 5. Perfect. Okay, excellent question. And if you needed help with 5, you probably needed help with 6. That's okay. Okay, so first, what are these things? Sleeping parabolas. And what's the equation for a sleeping parabola? X equals A, beautiful, y minus k squared plus h. Gorgeous. Okay, now what I need to do is identify these things for you. So the vertex is here. So this is the coordinate 2, 6. So h equals 2, k equals 6. Okay, and then what you need to do is find another point on it for your xy. I picked this one right here, which is 5, 3. So x equals 5, y equals 3. Okay, 5 equals a, 3 minus 6 squared plus 2. Question, you got this now, right? And then, do you guys know what the next step is? What do I always say? Well, yes, but get the 2 out of there before you do something silly. Parentheses are the correct order of operations next step. Anyway, I'm sure you've got it from there. Just remember that a negative squared is positive. Okay, you guys feel better about the mid chapter now? I hope. Okay, so let's talk about what we're doing today. Oh, goodness. Okay, that's a new screen for me. You guys remember where we left off last week? Okay, so we did all those axes. Remember drawing the axes? You're very upset about it. And then we had all the parent, you're upset. We had all the parent graphs, and then we drew their inverses and figured out what they would probably be just from common sense. Then we started working on the inverse of an exponential, and we realized that we couldn't do it because it was x equals. So we made it into a logarithm. Today we're working on logarithms, and we're going to be working on logarithms for the foreseeable future. There is a lot to learn about logarithms. You need to learn their properties. You need to learn how to graph them, how to solve equations with them. It's going to be a minute to settle into the logarithms. But we're going to pick up right where we left off, so don't worry. And homework is 68, 69, 70, and 72. And then there is my it's not really a joke, it's more of just a person's illustration of logarithm. Yeah, trust me, finding logarithm jokes is challenging. You should just be impressed that I found anything. I think tomorrow's might be slightly better than this, but anyway. Okay. Okay, when you're done writing this, I need you to get a graphing calculator, please. I'm checking the operating system of the older one. Just make sure that you won't be, you guys won't be having to do something challenging. Okay. All right. So this is where we left off last week. We had a temporary inverse. I just want to go back and remind you. So this is what our notes look like from last time. Oh, go ahead, go ahead. And we had an exponential of 3 to the x and y equals 3 to the x. We said our temporary inverse was x equals 3 to the y, so we just flipped them. And then we used what I call the Guinan circle to bring the y in front, and I got y inverse is log base 3 of x. Okay, so we're going to practice that again here with different numbers. First question I have is, what was the original function in this one? If the inverse is x equals 2 to the y, what was the original? Y equals 2 to the x. Yeah, no big deal. We just flipped the x and y. I just wanted to show you that I already did that part. Okay, and we're not going to write it like that because we can't put that in the graphing calculator because it's x equals. You can put it in Desmos, but not the graphing calculator. So we convert it to a logarithm. Y inverse equals log base 2 of x. Don't get worried about the order of things, really. You just look at the base. The base of this is 2. So the base of your log is going to be 2. Don't get upset about the order of things, just 2, 2. Okay, x equals 5 to the y is equivalent to y inverse equals log base 5 of x. So I'm going to say this a lot of times. The base of the exponent is the base of the log. The base of the exponent is the base of the log. If you can remember that, you can do the conversion easily. Okay, so now we're going to practice a different one, and then we're going to graph this one on the graphing calculator. So 64. Here's my original. It's an exponential. And what we're going to do is start to think about the steps of it. So you guys remember all last week we were writing the steps and then writing the inverse steps. If I plug something in for x here, what I write is 7 to the. What's the first step that I do to x? 7 to it. Okay, and what would it look like? It would look like it has a horizontal asymptote here somewhere, and then it would come along like this and take off like that. Okay, so this is all old stuff, regular old exponential. When I plug something in for x, the first thing I would do would be 7 to the x. And this is what the graph would look like. Okay, now red pen time. Inverse. Log base 7 of x. And what would be the first step that I would do if I plugged a number in here for x? It would be log base 7. And these two things undo each other. 7 to the undoes log base 7. These are inverse operations of each other. And what does it look like? Okay, so this is important. There's a very important detail here. The inverse, instead of having a horizontal asymptote, has a vertical asymptote. And the graph comes up and goes like this. Okay, once you get that, John, we're going to the graphing calculator. And I'm going to show you guys how to graph logs on your graphing calculator. And you're going to use this for good and not evil. These are one of those types. Oh, actually, I wanted to write something up here. Hold on. That's why I left this space. Okay. Sometimes having the words is really helpful. All right, so now we're going to graph both of the things on here. Don't worry about this. I was doing some stats. Clear everything out of your y equals. Oh, this is exciting. It's already set up blue and red, like I knew what I was doing or something, but I didn't. It's just totally like a coincidence. Okay, so in y1, put 7 to the x, 7 to the x. Okay, now this is how you do the log. Hit the math button. And by the way, you guys should know that if you can't find anything on the graphing calculator, the first place to check is the math menu. Just saying. Okay, now scroll down. It's down a ways. And you want to find this one that says log base. Okay, put yourself a little note over here. Okay, and then you get to put in the little things in little boxes. So put the 7 in the base and the x in the parentheses. So it looks like this, log base 7 of x. And these two things are inverses of each other. So to check that, I always like to put y equals x as my third one, just to get that line of reflection. And then hit graph. And see what happens. Okay. Good news and bad news. It looks kind of like what you expect. Okay, so we drew the pictures beforehand, right? Of what we know it should be. We know this goes on forever. Here it goes up. We know this goes on forever. What's happening with the graphing calculator? Yeah, it doesn't plug in infinitesimally small amounts of x next to zero. It's not going to think to do that. So it's not going to be like, oh, there's an asymptote here. And so I'm going to plug in little tiny values of x to show this going down. Desmos will do it. Graphing calculator won't. Okay, so what is the moral of the story here is that if you're going to use this tool to graph log graphs, you need to know that it goes on forever. And if you stop it right there, I will mark it wrong and I'll write you like a little dumb note, like, what, is this a square root, question mark? And you'll feel really silly. So what I'm warning you, this is one of those moments, like warning the whole class, if you stop your graph right there, I'm going to mark it wrong. So if you're using the graphing calculator, you need to know that this goes on forever. Even if the calculator doesn't show it, just keep it going down along the asymptote and you'll be fine because you understand what logs are supposed to look like and that it's not a square root. Everybody got that? You sure? You're not going to end your log graph and I'm going to have to write you a little note on there because I don't want to. All right, 65. Okay, so you guys remember when we started the inverses chapter, we wrote the steps, we wrote the inverse steps, and wrote the inverse. That's what we're going to practice here. Notice I've added stuff in. Oh man, multiple steps. Okay, but for A has only one step. If I plug something in for X, this is just X in the parentheses. What's the first thing I do to it? Log base 9. Plug a number in here. The first thing I would do to it would be log base 9. Okay, how do I undo log base 9? 9 to the something, 9 to the whatever it is. These two things undo each other. Log base 9 and 9 to the. My little line here, by the way, is just a little line, like where you would put, it's a blank. It's not a negative or anything. It's just like my 9 to the whatever. Okay, so my inverse would be y inverse equals 9 to the x. All right, let's go backwards. My original equation is y equals 10 to the x. Okay, what would be the first thing I would do to it? There's nothing that happens here. What's the only thing that happens to it? 10 to the. 10 to the whatever, 10 to the 1, 10 to the 2, 10 to the 6.5, you don't know, whatever you plugged in. Okay, what undoes 10 to the? Log base 10. So my inverse is log base 10 of x. Okay, now we're getting spicy. There's two things that happen. Whoo! All right, first, I plug something in for x. Parentheses first. What happens? Plus 1. Okay, after I plus 1, what would I do to it? Log base 6. Two steps, Mrs. Talbot, how could you? Okay, now we have to go opposite direction and undo. What's the undo of log base 6? 6 to the. And then minus 1. Okay, so following the steps, y inverse is 6 to the x minus 1 from everything. All right, last one. Plug something in for x. What would I do to it first? Times 2. I would times 2, and then I would 5 to the power. Okay, go backwards and undo. Log base 5. And then divided by, that's the what happened there? What is this? Divide, divide. Hmm. Can I just leave it? Can I leave it? Oh, I'm just knocking things over here. Divide by 2. Okay, y inverse equals log base 5 of x divide by 2 on everything. All right, we have one more problem and then we're done. And this problem coming up is, I think personally, quite a bit easier than this one. We'll see what you think. It looks long, but it's very quick, I promise. Here, let's just start here. These are like the ancient puzzle from the other day. That doesn't sound good. No, it sounds. Okay, quick question. Does everybody remember the puzzle from the other day? Does anyone in the room already know the answer for A just off the top of your head? Okay, if it makes you feel better, the answer is 5. Can you see the 5? And it's okay if you can't. Um, you can just put equals 5 if you understand how logs work. But for most of us, I'm just going to go through the motions of saying that I can't do that in my head necessarily. Okay, for A, what I like to do for this is I like to put equals X. Whenever there's a log with a base and a number value, I put equals X. This allows me to do the guidance circle. So let's practice the guidance circle. You start with the 2. That becomes your base. So the base of the log is the base of your exponent. Then you follow the little arrow around, and the X becomes your exponent. And then you keep following the little arrow around, equals 32. So 2 to the X equals 32. Okay, now you're wondering, now you maybe just this moment, you figured out why we have same base exponentials on last week's quiz and why we did them in warm-ups and stuff. That's because to do logarithm problems, you need to be able to do same base exponentials. So this is 2 to the X equals 2 to the 5. 32 is 2 to the 5. Cancel, cancel, X equals 5. Okay, so now you got the process down. Now you just need to work on your exponents. Okay, so equals X, guidance circle. Start at the base, 2 to the X equals 1/2. We've been working on this particular situation a lot. Is what? Yep. 2 to the X equals 2 to the -1. Cancel, cancel, X equals -1. Okay, try C on your own. 2 to the x equals 4. 2 to the x equals 2 squared. Cancel, cancel, x equals 2. Okay, so now you can see we've got some weird situations down here. Two to the x equals 0. This is no solution. You can sit with your calculator all day and not find 2 to the something that will equal 0. Just not going to happen. Two to the third equals x. This one, there's nothing to try to figure out. You just do 2 to the third is 8. Don't try to make like a same base exponential. This is already just x by itself. Two to the 1/2 equals x. Okay, this is actually the final answer, weirdly, but just to remind you, you could change that to the square root of 2 equals x, just as a reminder that half exponents are square roots. Okay, now we're going to do one more little thing that's only going to take a second, and this is just for the lazy people in the class. If you're lazy, you're going to like G, H, and I. If you're a person who likes to chug through the steps, then you'll probably never do it this way. Only you know if you're lazy or if you're a person who likes to chug through the steps. And there's no good way or bad way. They're both the same thing. They're both valid. It just depends on who you are. Yeah, it's a 1 point. Okay, now what are you saying, Mrs. Talbot? What do you mean by this? A person who likes to chug through the steps is going to put an x here, and then they're going to do 3 to the x equals 81, and then 3 to the x equals 3 to the 4th, and cancel, cancel, and x equals 4. Okay, but lazy people like me are going to say, oh, instead, why don't I just say that log base 3 of 3 to the 4th? Okay, because I just taught you a few minutes ago that the inverse of an exponential is a logarithm. These two things undo each other. So what I'm saying is these two things undo each other, and the answer is 4. So you can use inverse operations instead of the Guinan circle. Log base 7 of 7 squared is 2. Undo, undo. And then I is so amazing. Undo, undo. 1.2. You can do that if you understand that the inverse of an exponential is a log and they undo each other as long as you have the same base.